this. Well, we will be using another component which is called a relay. You know, a relay typically is a component. Okay, a relay is a component. Let me bring a relay here. Okay, this is a relay. Is a relay. So for seeing it better, let me zoom it to an extent so that all of you can see it better. This is a relay. A relay has one coil, a coil of several thousand turns over an iron piece, and when the current flows through this, whether this direction or this direction doesn't matter, when the current flows through this, there is an isolated switch. We call this an isolated switch, and it has got 3 points. One is a common point. This is called common point. This is called NC point, that is normally closed. Normally closed means when there is no power given, this is in this position, and when the power is given, this switches from this to this. Now let's see how it really behaves. Now okay, so what I do, I take a battery. I take a battery, I put the battery here, and okay, I take a switch, put a switch here, and connect this to this, and connect this to this, and connect this to this. Right, now let me see how the relay is really working. Right, now when I give power to the coil, you see this point, no power, power, no power, power. So this point is a switch which can be utilized for any purpose, and let's see how we utilize it for some purpose. Okay, we go back to the same circuit that we have at the top, and we will replace the transistor with a relay. Now let's go over to this, disconnect this, and disconnect this, and what I do is I take a relay, I put the relay here, right, and okay, if you are not able to see it better, let me zoom it. Right, and what I do is I take this positive supply, with the obviously this is positive supply. When the switch is closed, this positive supply is available here, and I connect this to this. Alright, now let's see how it behaves. Now right, that means right. So what we have seen here, that only when the current flows in the base to emitter circuit, then only this switch closes, we have discussed. So after the switch closes, this current flows this way, and the path is complete, and that is how this switch changes to this side. Right, let's operate few more types. Right, you look at this, this. So this sort of arrangement can be utilized for certain other activities also. For example, if I take an AC supply, say I have a AC supply, and let me take a lamp, supposing I put all of them in series, the lamp, AC supply, and what I do is I connect here, and let me connect this, right. Now what we find here, we find there is a AC supply, there is a bulb, and I have connected in such a fashion. We will see how it behaves. Now for certain simulation purposes, let me call this lamp as 12 volt. Okay, and supply also I can take any voltage based on the lamp, but then I will also make it the same voltage. It can be 220 volts, it can be 300 volt, 400 volt, whatever, because this switch is nothing to do with this supply. This is completely isolated, and we call it magnetically coupled. That is why this actually the relay is called an electromagnetic relay. It's not a normally people call it a relay, but it's an electromagnetic relay. Some people have a confusion or a misinterpretation that the relay is a protection relay. Relay actually is not a protection relay. Protection is incidentally is one of its activities, but actually the relay is used for this kind of purpose. Okay, now let's again power this. Let's see what is happening. We have the AC supply available here, but this lamp is not glowing. Why? Because the path is not complete. Okay, it goes here, goes here, goes stop. It can glow only when this changes to this side. Now we'll see this. Now let's use this. You see, now the lamp starts glowing. Why the lamp starts glowing? Is because this switch has come to this side. The path is complete. Once the path is complete, obviously the lamp will glow. Now see it few more times. This way, this way, this way, this way. So this is how we use a transistor as a switch to switch on another load which is completely independent of any supply. This could be a low voltage supply, this could be a microcontroller supply, this could be something, but then this could be any higher voltage, AC voltage, DC voltage, whatever it is that we choose. So this is how a relay is used in switching on an arrangement like this. Actually, in certain electronic circuits, we use number of relays. When we use number of relays, obviously we will be using number of transistors, and then the current which has to flow in the base also has to be coming from some other source. Those all details we'll be discussing little later. Now let's, instead of this, now supposing I would like to go in for some kind of arrangement where I will run a motor. Okay, now let's stop this. Now I close this. Okay, I stop this. I take another set of battery or a DC source, whatever it is. Now let me take another source of battery here. Right. Okay, I connect it to this place and I take a motor. Say for example, I take a motor here. Right. I connect this to this and I connect this to this. Right. Do it little more again. Okay, now let's see. Now in the same fashion, when I power this, okay, there is some simulation difficulties here. Okay, so we will go these sort of things little later. Okay, so this is what we understand, that how a relay is used